In this video, we're going to go through several word problems that require the use of quadratic equations. In this video, I'm assuming that you already know how to solve quadratic equations. That is, you're familiar with the square root property. You know how to solve by factoring. You know how to factor by grouping. You know when to factor by grouping. And you're familiar with the quadratic formula. I'm not going to stop and teach how to do these methods. We're applying these methods today. The concentration of this video is not so much how to solve quadratic equations, but how to set them up when you're given a word problem. So the full solutions to this can be found in the description. There's a PDF in the description. And I'm going to do one problem, then you can pause the video and do another problem. So there's this kind of back and forth. The last three are a bit more challenging, so I'm just going to do those all the way through. But anyways, let's get started. So example 1, we're going to talk about consecutive integers. The first one here says the product of two positive consecutive integers is 210. Find the integers. Let's make sure we know what we mean by consecutive. The integers 4 and 5, those are consecutive, right? They're in a row. The integers 18 and 19, those are consecutive. They are also in a row. But the important part here is noting that to get from 4 to 5, I need to add 1. And it's the same thing from 18 to 19. To get from 18 to 19, I would add 1. That's an important piece of this. So, say that our first integer that we're trying to figure out is x. Well, the integer that comes after that, the consecutive integer, is going to be x plus 1. And we are multiplying these because we want the product. The product is 210. So this right here is the quadratic equation that we need to solve. So I'm going to start by distributing the x. This gives me x squared plus x equals 210. And then I need to subtract the 210 to the other side, which gives me x squared plus x minus 210 equals 0. Good. Let's factor this. The negative 210 goes on top. I'm going to put a 1 on the bottom. Where did the 1 come from? The 1 is technically the coefficient of the middle term here. There is a 1 in front of the x. So we need two numbers whose product is negative 210 and whose sum is 1. And it's okay, right? If you need to use a calculator, you know, if there's a little bit of guess and check on a calculator to figure out what two numbers have a product of 210. And that's going to be 15 and then negative 14, right? And then 15 minus 14 is going to give you the 1 on the bottom. So good. This trinomial factors to x plus 15 and x minus 14. And we need to check both of these. Again, I'm assuming you're familiar with doing this process, right? Maybe x plus 15 equals 0, and maybe x minus 14 equals 0. You need to check both. The first one would give us a negative 15, and the second would give us a positive 14. We want the positive one. The problem is asking specifically for the positive solution, so we're going to throw out the negative 15 and keep the 14. So the 14 is the first of these two positive consecutive integers, which means the second integer is 15. The answer is 14 and 15. And check it, right? 14 times 15 is 210. We basically did all of that when we factored. Good. So, pause the video, try the second one on your own. The answer is 18 and 19 there for you, but see if you can write the equation and go through the process and arrive at the solution on your own. Example 2, we're going to do the same thing. But now our integers are either going to be even or they're going to be odd. It doesn't matter. The problem is done the same way. I'm going to do the odd version. Then you can try the even version. So here we go. The product of two positive consecutive odd integers is 143. Find the integers. Okay, let's make sure we understand what's happening here, right? Some consecutive odd integers might be 3 and 5. Those are consecutive and they're odd. Another pair would be 17 and 19. The important part here, though, is realizing that to get from 3 to 5, you need to add 2, or from 17 to 19, right? You need to add 2. The difference between two consecutive odd integers is going to be 2. So, if x is the first of our unknown positive consecutive odd integers, the next one is going to be x plus 2. Right? In example 1, we had x and x plus 1. Now we have x and x plus 2. Their product is 143. So this is the quadratic equation that we need to solve. We'll start by distributing. This gives us x squared plus 2x equals 143. I'm going to subtract the 143 to the other side. And we need to factor this. If you feel like there's a little bit of circular reasoning going on here, I get it. It's basically like, to find which two positive consecutive odd integers have a product of 143, I need you to find me two numbers that have a product of negative 143 and have a sum of 2. It's kind of funny. I'm just telling you to do it, right? Do it. So use a calculator. Totally okay. A little guess and check. You're going to find that the numbers here, well, let me check before I say it. 11 and 13, right? Now, the 13 will be positive and the 11 will be negative. So our trinomial factors to x plus 13 and x minus 11, which gives us solutions of negative 13 and 11. So again, I just skipped a step here. I went straight from the factored to the answer. We want positive. We want our answer to be positive, so we're going to throw out the negative 13. Which means the first of our two positive consecutive odd integers is 11, which means the second one is 13. And you can check that 11 times 13 is 143. Good, pause the video, try the next one. The only difference, instead of odd, it's even. But even numbers are also 2 units apart. Consecutive even integers are also 2 units apart. So it's done the exact same way. Pause the video and see if you can get the correct solution. Example 3, we're going to deal with the area of a rectangle. The base of a rectangle is 1 centimeter less than 4 times its height. Find the base and the height if the area is 33 centimeters squared. We have to translate this first sentence into an equation. It says the base, I'm going to use B for base, is 1 centimeter less than 4 times its height, right? 4 times the height, that's going to be 4 times h, and then 1 less, minus 1. We need the area formula for a rectangle here, which is base times height. And now we're going to substitute into this everything that we know. We know that the area is 33. So let's start by putting the 33 there. We know that the base is the same thing as 4h minus 1. So we're going to substitute that out. And then we're going to leave our h alone. We don't know anything about h. Let's solve for it. So here's the setup. We now have the quadratic equation that we need to solve. I'm going to start by distributing the h. This gives us 33 equals 4h squared minus h. I want the 33 on this side, and I'm actually going to just flip the whole equation here. So I have 4h squared minus h minus 33 equals 0. All right. Notice another difference in this problem. The leading coefficient is 4. In the previous examples, the leading coefficient was technically just 1. I should have written it here. The leading coefficient was technically just 1. When the leading coefficient is greater than 1, you need to factor by grouping. So if you're unfamiliar with that process, I would recommend, going to another video and brushing up on that. I don't want to lose you here, but I'm not going to, break it down. The top number here is negative 32. The bottom is negative 1. The negative 32 came from 4 times negative 33, right? The leading coefficient times the constant. I need two numbers whose product is negative 132 and whose sum is negative 1. That is going to give me negative 12 and 11. So the process here, I'm going to split this up into a negative 12h plus 11h minus 33. Notice that I haven't changed the value of the original equation. Negative 12h plus 11h is negative h. I've just split the negative h up using the negative 12 and the 11. But anyways, that's factor by grouping. Now I'm going to, here's the actual grouping part. I'm going to group up the first two terms, and those are separated from the second two terms. What could I factor out of 4h squared minus 12h? We could factor out of 4h, leaving behind h minus 3. From the second two terms, I can factor out 11, which leaves behind h minus 3. And this is how you know you've done this correctly. The h minus 3 matches, right? That factor has to match for this to work. And that's going to leave us with 4h plus 11, h minus 3 equals 0. So the two solutions, I'm skipping steps here. The two solutions are negative 11 over 4 and 3. But it would not make sense for the height of a rectangle to be negative. So we're going to throw out the negative 11 over 4, and we're going to use a height of 3. The height of this rectangle is 3. Now we need the base. We can find the base by making use of the very first thing that we wrote, right? The base is 1 less than 4 times the height. The height is 3, so that's going to be 4 times 3 minus 1, 12 minus 1, which is 11. So the base is 11 centimeters and the height is 3 centimeters. That right there is the solution. Good. So go ahead, if if you're just passively watching this, I would strongly encourage you, get out a pen and a paper, pencil and paper, and pause the video and try the next one. The answer is there for you, but see if you can set it up and go through the process and arrive at the correct solution on your own. Example 4. Same thing, we're just going to do the area of a triangle this time. The height of a triangle is 3 feet more than twice its base. Let's just go and pause there, right? The height of a triangle is 3 feet more than twice its base. We need to translate that. The height is, so h equals 3 more than twice its base. Twice its base, right? That's another way of saying 2 times. So 2 times the base, and it's 3 more than that, so plus 3. We need the area formula of a triangle. That's 1/2 base times height. And let's plug in what we know. We know that the area is 13.5. B for base, we don't have anything extra about the base, so we'll just leave that alone. But we know that the height is the same as 2b plus 3. So we're going to make that substitution. Instead of putting h, we're going to put 2b plus 3. And this right here is the quadratic equation that we need to solve. So I'm going to move this over, give myself a little room. Let's talk about this 1/2 right here. How do I move the 1/2 to the other side, or how do I cancel it out? We can get that done by multiplying both sides of the equation by 2, right? 1/2 of 2 is 1. So those will cancel out, and 2 times 13.5, well, that's going to be 27. So we now have 27 equals b times 2b plus 3. All right, okay, so no more decimals, nice and clean. Let's go ahead and distribute the b there. That gives us 27 equals 2b squared plus 3b. And I want the 27 on the other side with these guys. That's going to be 2b squared plus 3b minus 27 equals 0. Good. All right. Pay attention, right? The leading coefficient is greater than 1. This means we need to factor by grouping. Factor by grouping. The top number is going to be 2 times negative 27, which is negative 54. My bottom number is going to be that 3 right there. So I need two numbers whose product is negative 54 and whose sum is 3. That's going to be 9 and negative 6. So let's set it up for grouping. We split the 3 using the 9 and the negative 6. This gives us 2b squared minus 6b plus 9b minus 27 equals 0. Good. Split it up so we can group. The first two terms, we could factor out a 2b, which leaves behind b minus 3. From the second two terms, we can factor out a 9, which leaves behind b minus 3. So this factors to 2b plus 9 and b minus 3 equals 0. All right. I'm going to add a room here on the bottom, so I'm going to just take this right here. I'm going to take this. Can we squeeze it in right there? Oh, I'm going to make it smaller. Oh, this really bugs my perfectionistic desires here, but that's okay. We're just going to deal with it. The first one gives you a solution of negative 9 over 2, and the second one gives you a solution of 3. And again, we're dealing with a triangle here. It doesn't make sense for it to have a negative height, so we're just going to throw out the negative 9 halves, and we're going to use the 3. Sorry, I should have said base. It doesn't make sense for it to have a negative base, so the base here is going to be 3. The base is 3. I'm writing at the top now. Now, how do we find the height? We're going to make use of the very first thing we wrote down, right? The height equals 2 times 3 plus 3, which is 2 times 3 is 6, plus 3 is 9. So the base is 3 feet, and the height is 9 feet. There we go. Awesome. All right. Pause the video. Try the your turn version on your own. Same exact problem. The answers are there below for you. See if you can successfully set this up and go through the steps and arrive at the solution on your own. Example 5. We're going to bring in the Pythagorean theorem, right? A squared plus b squared equals c squared. You've heard of that before. So here we go. My turn. The hypotenuse of a right triangle is twice the length of one of its legs. Find the length of the leg and the hypotenuse if the length of the other leg is 6 inches. So let's go draw this out a little bit. It doesn't have to be perfect, but just to get an idea of what we're working with here. I'm going to call the leg down here x. We don't know what it is. However, we do know that the hypotenuse is twice the length. So that's another way of saying 2 times, right? So 2 times x, 2x. And the length of the other leg is 6, right? So here are the sides we have available. We'll call the bottom one A, the side one B, and the hypotenuse C. And we're going to use a squared plus b squared equals c squared. Our A is x, so x squared. Our b is 6, 6 squared. And our c is 2x, so 2x squared. This gives us x squared plus 36 equals. Now, make sure you square everything in the parentheses right here, right? 2x parentheses squared is 4x squared. All right, I'm going to move the x squared over here by subtracting it. This gives me 3x squared equals 36. All right. Again, notice the difference in the situation that we have here. In previous problems, we've always had a term in the middle of the equation. Right here, we had a term in the middle of the equation. We don't have that here, which actually makes this much easier to solve. All we have to do is divide both sides by 3. This gives us x squared equals 12. And then, right, to get rid of a square, we square root. But don't forget the square root property. Technically, x is going to equal plus or minus root 12. So if you're doing just an abstract equation with no context, with no word problem, yes, you would stick with the plus or minus. But here we're dealing with an actual triangle that has an actual leg, and it wouldn't make sense for the leg to have a negative length. So we're actually just going to use the plus root 12 or the positive root 12. You do need to simplify this. 12 can be broken down into 4 times 3, which is 2 root 3. And we're doing inches here, so 2 root 3 inches. You can round that, you know, plug that into a calculator. That's about 3.464. 3.464 inches. So whatever, you know, those are both perfectly fine answers. 2 root 3, which is about 3.464. Good. Okay, pause the video, try the next one. Same exact thing. See if you can find your way to the correct solution. Example 6, we're talking about the height of a projectile. So that is something that's shot up into the air. For these problems, right, this is not a physics class, so we're going to try to keep this as simple as possible. In these two examples, well, in this example, in both problems, the object is going to be shot straight up. Good. So my turn here. An arrow is shot straight up from a height of 6 feet with an initial velocity of 30 feet per second. Find how many seconds it will take the arrow to hit the ground. And here's a formula for this. So don't be intimidated by the formula. H stands for height. This v sub 0 right here, that's the initial velocity. And h sub 0, that's the starting height, right? The starting height here is going to be 6. And again, I'm using 6 as the rough height of the person who's shooting the arrow, right? Maybe they're a little bit shorter because they have their hands up in the air, but you get the point. The arrow is not being shot from the ground. The arrow is being shot from a person. So, using this formula, right, what is h? What are we trying to find? Well, we're trying to find when it hits the ground. What is the height when the arrow hits the ground? The height of the arrow will be 0 when it hits the ground. The initial velocity is 30, and the initial height is 6. I'm going to go ahead and move everything to the other side, right? I want all this over here. Or you could also get this done by multiplying everything. Sorry, that looked like a -1. I should be multiplying by -1. If I multiply by -1 or move everything over, it's going to give me 16t squared minus 30t minus 6 equals 0. And also notice that everything here is divisible by 2. So I'm just going to divide out everything by 2 to get smaller numbers. 8t squared minus 15t minus, divide by 2 is 3 equals 0. And, okay. Let's see if this is factorable. I'm looking for two numbers that multiply to -24. The -24 comes from 8 times -3, -24, and whose sum is -15. So what are some factors of -24? Well, we have 2 and 12. That's not going to get us 15. We have 4 and 6, but 4 plus 6 is 10. 8 and 3. 8 and 3 has a sum of 11. So this one is not factorable. Right? So far, every example has been factorable. This one is not. So when you can't factor, kind of the go-to, the backup, when all else fails solution is the quadratic formula, right? So that's going to be the -b plus or minus the square root of b squared minus 4ac over 2a. I'll write it out. I hesitate, but you know, you've seen this before. This is what we're about to do. So here, my A is going to be 8, my B is -15, and my C is -3. I need to plug those in. This is going to give me T. You know what? I need the room. There's the quadratic formula right there. But it's going away. Bye-bye. Delete. Okay. So we have T equals -b. Now watch out for the double negatives, right? That is -15 plus or minus b squared minus 4ac all over 2a, which is going to give me 15 plus or minus. All right, I'm going to punch that other part into a calculator. 321 over 16. Let's talk about this plus or minus again, because same situation we had before is, yes, technically speaking, there are two solutions here, but we do have context. We don't care about the negative time. So we're actually only going to move forward with one of the two options, right? You have two options, plus or minus. We don't want the minus because we don't want negative time. So we're just going to do 15 plus root 321 over 16. And again, this is irrational. Just go ahead, type it into a calculator, and we're going to round our answer. This gives us about 2.05 seconds. So, wow. I guess I don't really have a good understanding of what 30 feet per second is, 30 feet per second. Because this arrow would have only been airborne for a little over 2 seconds. So I imagine arrows are probably shot much faster than 30 feet per second. But anyways, that's the math. That's how you would do this. Pause the video, do the same thing. In the next problem, we're going to have instead of a bow and arrow, you're going to shoot a gun. But you're shooting it straight up. See if you can set it up and solve it. Spoiler alert, you will have to use the quadratic formula again. And see if you can come up with a solution on your own. Okay. For the last 3 examples here, there's not a my turn, your turn. There's just the example. I'm going to do them all. They're a little weird, but I will teach it to you. Sorry, I need to adjust a little bit. Get a little uncomfortable here. Okay. Example 7, river current. A ferry transports passengers between 2 docks along a river. The speed of the ferry is 10 knots, and the docks are 12 nautical miles apart. Find the speed of the river current if a round trip takes the ferry 3 hours. And guys, don't be distracted by the units here. 1 knot is the same thing as 1 nautical mile per hour. So instead of doing regular miles per hour, doing nautical miles per hour, not a big deal. The math is still the same. It's just a different unit. So realize that when the ferry is going upstream, it is going against the river, which means the river is slowing it down. So the upstream rate is going to be the speed of the ferry, which is 10, minus the speed of the current, right? The current is working against the ferry. But when they're going downstream, the river is pushing the ferry. So their speeds are working together. Thus, the rate would be 10 plus c. Now we know the distance. Let's see. Yes, the docks are 12 nautical miles apart, so the distance of each trip would be 12 miles. And we don't have much going on for the time here, right? They do tell us that a round trip takes 3 hours, which means that, you know, the sum of these two things will be 3, but we don't know exactly how that's broken up, right? Is it 2 and 1? Or is it 1.5 and 1.5? Well, it can't be 1.5 and 1.5 because there's different rates going up and downstream. So here's how we're going to set this up. You are familiar with the formula distance equals rate times time. But we need a different perspective of this. I'm going to divide both sides by the rate, and this is going to give me that time equals distance divided by rate. Same formula, different perspective. So the time, again, equals distance divided by rate. So for upstream, that's going to be 12 divided by 10 minus c. For upstream, that's going to be 12 divided by 10 plus c. And again, these two things need to add up to a total of 3 hours. So 12 over 10 minus c plus 12 over 10 plus c equals 3. This right here, believe it or not, is, well, it's not a quadratic equation, but it's going to be. This is the equation that we need to solve. Here's how you're going to solve this. You need to use the least common denominator, which in this case is 10 minus c times 10 plus c. If I multiply the entire equation by that LCD, I'm going to get rid of all the fractions, which is wonderful. So you can do this. You can multiply the entire equation by something. Just make sure you distribute it to everything. When I distribute this to the first fraction, the 10 minus c's will cancel out, which leaves me with 12. Well, I want blue back. Which leaves me with 12 times 10 plus c. When I multiply this times the second fraction, the 10 plus c's are going to cancel out, which leaves me with 12 times 10 minus c. However, when I multiply the LCD to that 3, there's nothing to cancel out with, so we get the whole thing. 3 equals 10 minus c times 10 plus c. All right, we need to distribute this, distribute that, Make sure you FOIL this over here. And this is going to give us, we got 120 plus 12c plus 120 minus 12c. Ooh, that's going to be nice. Over here we have 3 times 100 plus 10c minus 10c minus c squared. Ah, there it is, right? There's the square. That's what makes it quadratic, right? All right, cool. You can see right here the 12c and the negative 12c are going to cancel out. Make sure we add the 120s. That gives us 240 equals, over here, the 10c and the minus 10c will cancel out. So we have 3 times 100 minus c squared. Oh, bad penmanship. Here we go. All right, let's go ahead and distribute the 3. That gives us 240 equals 300 minus c squared. Rearranging things a little bit, I will have, whoa, 3c squared. There we go. Rearranging things a little bit, I will have 3c squared equals 60. Here we go. Ah, this is great, right? We can solve these straightforward. We don't need a factor. We don't need to use the quadratic formula. You just start by dividing both sides by 3. So c squared equals 20. Square root both sides to get rid of the square. And we have c equals plus or minus root 20. But again, we technically have 2 options here. We have plus root 20, we have minus root 20, right? A positive solution and a negative solution. And if this problem had no context, we would keep both of them. But this problem does have context, right? It doesn't make sense to say that the current of the river is negative, that the speed of the current is negative. So we're actually just going to use the positive root 20, which can be simplified, right? We could break 20 down to 4 times 5, which is 2 root 5. Knots, right? That's the unit here, which let's go ahead and punch that into your calculator, and you get that that's about 4.472 knots. And again, if this were a regular problem with miles per hour, we would have just put miles per hour. But I wanted to make things a little more interesting. Good. There you go. So that's that entire problem right there. Nice. Okay. Example 8. Thanksgiving dinner. Right? That's coming up pretty soon when I made this video. Here we go. If Annie and Kim work together, they can prepare Thanksgiving dinner in 4 hours. Individually, it would take Kim 1 hour longer than Annie, 1 more hour than Annie. Find how long it would take each of them to prepare the dinner if they were working alone. So, what do we know? We know that together, how long it will take them to prepare the dinner is 4 hours. Now we don't know how long Annie would take alone, so we're going to call that X. But we do know that Kim will take 1 more hour, so Kim's going to, whatever X is, Kim is going to take X plus 1 hours. Okay, this is a little weird, but notice we have hours per dinner, right? How many hours it would take them per preparation. We're going to flip this into dinners per hour. For example, at the bottom here, if it takes them 4 hours to prepare dinner together, then each hour they would have prepared a quarter of the dinner. You reciprocate it. Right? Hours per dinner becomes dinners per hour. So X becomes 1 over X, and X plus 1 becomes 1 over X plus 1. And the sum of these two right here is going to equal 1/4. However dinners Annie can put together per hour plus however many dinners Kim can put together per hour is going to equal 1/4. That's the setup here. So similar to the last one, we need an LCD. The LCD here is 4x times x plus 1. If we multiply the entire equation by the LCD, it's going to get rid of all the fractions for us. When I multiply this by the first fraction, the x's will cancel out, which leaves behind 4 times x plus 1. When I multiply the LCD by the second quantity, the x plus 1's will cancel out, which just leaves behind 4x. When I multiply the the LCD by the last fraction here, the 4's will cancel out, which leaves me with x times x plus 1. And this right here is the quadratic equation that we need to solve. It doesn't look quadratic yet, but let's go ahead and distribute everything that we can. This gives us 4x plus 4 plus 4x equals x squared plus x. I'm going to move everything on one side. This gives me x squared minus 7x minus 4. You think about that, 8x, negative 7. Yeah, okay, great. Again, I skipped a lot of steps there. I'm assuming that you're comfortable with the algebra. If you're not, you can look. Again, the solutions there's detailed solutions in the description. You can look those up. So I need two numbers that have a product of -4 and have a sum of -7. Well, the only factors of 4 are 1 and 4, and 1 plus 4 is 5. So there's no way we're going to get a -7 out of this, which means, drum roll, right, you need to use the quadratic formula. I have a little bit more room here, so I'll write it again. -b plus or minus b squared minus root minus 4ac with a root all over 2a. We got to use that, right, because this is non-factorable. My a is 1, my b is -7, and my c is -4. So x equals, we got a double negative again, -7 plus or minus -7 squared minus 4ac under the square root all over 2a. Simplifying gives us 7 plus or minus, all right, 49 plus 16, 65, root 65 over 2. All right. So I'm repeating myself a lot here, right? But if this was just a problem with no context, that would be the answer there. You technically have two answers, a plus and a minus. However, this problem has context, and it wouldn't make sense to say that it takes Annie negative amount of hours, right, to prepare dinner. So we're just going to go with 7 plus root 65. Whoa, that's better, over 2. Which is going to give us, we'll approximate this, 7 plus root 65. Sorry, struggling over here. Here we go. Divided by 2. 7.531. All right, so if Annie was working on her own, it would take her about 7.531 hours to finish. Remember that takes Kim 1 hour longer. So Annie is at 7.531 hours. Kim would be 1 more hour, which is 8.531 hours. There you go. So I think the weirdest part of this problem, right, again, is just going from hours per dinner to dinners per hour. I'm going to say it one more time, but if they can complete, well, if it takes them 4 hours to complete one dinner, then they finish a quarter of the dinner each hour. That's what's happening here. So you reciprocate. All right, good. There's the whole thing. You can see the whole thing, you know, check out the solutions in the description. Those are there for you with much better penmanship. Right now, penmanship's, it's acceptable, but it's a little rough. Last example, 9, island trip. It's going to be the same here as the Thanksgiving dinner problem. So if a boat uses both of its engines, it can make it to the island in 3 hours. If it just used the backup engine, it would take it 8 hours longer than if it used only the primary engine. Find how long the trip would take with just the primary engine. So be aware, again, the 2 engines in this boat are not the same. One of them is bigger and stronger than the other. But if both of them are in use, the trip would take 3 hours. We don't know how long the primary engine would take, and we don't know how long the backup engine would take, but we do know that if the backup engine was working alone, it would take 8 more hours. So we're going to use x and x plus 8. Same thing. If both engines can complete the trip in 3 hours, then each hour they complete a third of the trip, right? We switch from hours per trip to trips per hour. Reciprocating the other quantities gives us 1 over x and 1 plus x over 1 over x plus 8. And this plus this will equal the 1/3. However much of the trip the primary engine covers, plus however much of the trip the backup engine covers per hour, will amount to 1/3 of the trip per hour. Think about that. So our equation here is 1 over x plus 1 over x plus 8 equals 1/3. We're going to use the LCD of 3x times x plus 8 to clear the fractions. Wow, how do you know we're at the end of the video? Because my penmanship sucks. Alright, here we go. It's okay. Doesn't have to be perfect. When I multiply 3x times, I'm just going to say the LCD. When I multiply the LCD by the first fraction, the x's are going to cancel out, which just leaves me with 3 times x plus 8. When I multiply the LCD by the second fraction, the x plus 8's will cancel out, which just leaves behind 3x. When I multiply the LCD by the 1/3, the 3's will cancel out, which just leaves me with x times x plus 8. Distribute everything that you can. This gives us 3x plus 24 plus 3x equals x squared plus 8x, right? There's our quadratic, right? The x squared. That means we're dealing with a quadratic equation here. If I move everything to the same side, I get x squared plus 2x minus 24 equals 0. Again, you should always check if it's factorable, because I think factoring is way cleaner than the quadratic formula. You may have your own preference. But I need 2 numbers that multiply to negative 24 that add to negative 2. That's going to be 6 and negative 4. So this one's nice and clean this time. Factoring gives me x plus 6 and x minus 4, which correspond to a solution to solutions of negative 6 and positive 4. Great. But again, we have context this time. We're talking about the amount of time it takes a boat to travel. It would not make sense to say -6 hours. So we're going to throw out the -6. We're going to keep the 4, which I believe that's all the question was asking for. How long would it take the primary engine to complete the trip? We let that be x, and we got that x equals 4. So, there you go. Whoop. But, you know, just to bring it all home, is the backup engine takes 8 hours longer. So the primary, right, the primary we just figured out takes 4 hours, which means the backup engine would take 12 hours. Which makes sense. It's the backup engine. It should take it a lot longer. I don't know, that is a lot longer though. But anyways, you get the point. Cool. If anything in this lesson was unclear, again, I would encourage you, go look at the PDF in the description. The solutions are much more detailed. But if things like factoring by grouping confused you, right, go back and look up how to factor by grouping. If you're unfamiliar with the quadratic formula, go back and look up how to use that. But this is how we can apply it to word problems. Thank you for sticking around. Hope this helped. If you're watching this at the right time of the year, happy Thanksgiving.